So I in last class I discussed with you uh, the branch point, and I told you that we will discuss branch point uh, integration. Okay, so I just told you how to know where is the branch point, and I also told you that branch point is also a kind of singularity. Branch point is also a kind of singularity. So if I give you an example that suppose you have omega is equal to z to the power 1 by 3. Okay, suppose this is your function, omega is equal to z to the power 1 by 3. So uh, to represent this, we need three different Riemann sheets. So those sheets are those planes on which this complex function will be represented are known as Riemann sheets. So you need three different Riemann sheets to represent that. For example, z to the power half, you need two Riemann sheets. For this, you need three Riemann sheets. So they are like this. Suppose you have this one plane, okay, and you have like this another plane. So these are two different sheets. They will represent so there are three different sheets, and suppose for z is equal to half, if I take, so you will have two different Riemann sheets like this, huh? Two Riemann sheets, and they will be connected by a point. So I cannot hold it like this, but you consider them as parallel, except that at the center point they are same. So that point will be here. Which point? Z is equal to 0. So it is better to understand in terms of this. Omega is equal to Z half. So you have two sheets, but at Z is equal to 0, the values are same. Can you see that? So Z to the power half is a multi-valued. I told you that this will give two different values. So when I take Z is equal to 0, so at that point both are same. So that point is known as actually branch point. That point is known as branch point. In the case of logarithmic, I told you that if you take full circle, you just arrive at a different value. So you can understand that in terms of a multi-level car parking. Like in a multi-level car parking, if you take one full rotation, you arrive at a same point which is above the previous point. Can you understand that? So it is like this, that you are on an entirely different plane. So those planes, those sheets are called Riemann sheets. Okay. So we have to just understand two things. Number one is how to know the branch point, how to isolate the branch point, and the second thing will be the contour integration that I will discuss in some time. So one more important thing is that what is branch cut? What is a branch cut? So you will have two points, two branch points, and you join it by whatever type of contour you like. So that will be known as branch cut. So suppose there are 2 points, two branch points, Z0 and Z01. So this cut connecting the two branch points will be known as branch cut. These cuts connected connected by two branch points is known as branch cut. Okay, so even to know that uh, this is a branch cut is also important. And let me take one problem. Suppose I take a problem, fz is equal to 1 upon z ln of 1 minus z. Okay, suppose this is the problem and we have to tell all type of singularities. Okay, so a, you can see from here z is equal to 1 and infinity are branch points. This is first type of singularity.
Sir, it's integer, so why infinity will be there?
Sorry?
Sir, 1 minus z to the power is integer, so infinity should not be the branch point.
No, that means you did not pay attention last time. It was like this. If it is here, it is only log of z minus z0. Okay, the question of integer will come when there is another one also, na? See your notes. So if you have z minus a, z minus b, then there will be a question of
Sir,
integer.
you had taken one example of ln z minus to the power half, single one.
ln?
ln z minus to the power half.
No, there was no such example.
Yes, sir.
ln z to the z minus 2 to the power half. Where was that example?
Yes, sir. You have 2
No,
and infinity. You
no,
had
no,
it
no,
as branch.
no, no, no.
Yes, sir.
We had this example, uh, z minus 2 to the power half. Suppose this may be an example, and then I took example ln of z minus 2 z minus 1, something like this.
No, sir. Z minus to the power half.
No, sir, log is
I don't know. I had written.
टू की पावर हाफ भी क्वेश्चन था
क्या था?
सर ln z माइनस टू की पावर हाफ ये क्वेश्चन कराया था सर आपने और इसमें ब्रांच पॉइंट थे 2 एंड इंफिनिटी
नहीं दोनों मतलब या तो भाई या तो मैं पावर्स डिस्कस कर रहा हूँ या मैं लॉग डिस्कस कर रहा हूँ. दोनों दोनों का कोई मतलब नहीं है ना. अगर लिख दिया होगा तो गलती से लिख दिया होगा. भाई मान लो मैं ये लिख रहा हूँ ln z minus 2 to the power half, तो इस हाफ का कोई मतलब नहीं because that will come forward. So only z naught will be the point of.
But sir, you have written. You wrote infinity also.
What I wrote? Tell me the question.
Yes, sir. Question was that which you have written right.
Fz is equal to
ln z minus 2 to the power half. And you told 2 and infinity will be branch point.
obviously 2 and infinity will be branch point.
But sir, you told that half will come in the multiplication.
Half has nothing, no benefit, na? It will come like this. So it is just like ln z minus 2, na? This is not important. So z is equal to 2 and infinity will be branch point, yes? Correct?
Sir,
But
you
sir, now
mentioned also
integer a plus b is integer, so infinity will not be.
Where is a plus b? That is what I am asking. Where is a plus b?
Only a is there.
There is no a plus b. So if you take it like this, see this question. So this will become this question is, you have powers now. So power is 1 and 1, which is 2.
Yes, sir.
Okay. Or it is like this. This is a very good question to understand. So z is equal to 2 and 1, and infinity will not be the branch point.
Yes, sir. If there is nothing in multiplication, then infinity will come.
Don't give sentences. Just yes or no. If you don't understand, then you ask, because that may confuse others. So if
Multiplication and I understood.
that is also okay, na? That is also okay. Multiplication will become log a plus log b.
Hmm.
So where is the problem? This will become log a minus log b. Okay. So all examples are clear. If I write it like this, then this half is not important because that will come forward, na? Okay. So that half will be, if I take it like this, z minus 1 to the power half and z minus 2. Suppose example is like this, then z is equal to 1, 2 and infinity are the branch points. Okay.
For only L and Z, what are the branch points?
0 and infinity. So suppose it is fz is equal to ln z. So 0 and infinity are the branch points. Okay. Let us see this. So a, 1 and infinity are the branch points. This is the first point. Second point is there any other singularity? So for that we will have to see it like this. Fz is equal to 1 by z, and open this log of this, it will be minus z square by 2 dash dash dash. Okay. So that means what is z is equal to 0? It is a removable singularity, like sin x by x. Removable singularity. Okay. So z is equal to 0 will be a removable singularity, and C also write one sentence that z is equal to 0 is a singular point at all sheets except at principal Riemann sheet. Principal Riemann sheet. Okay. And point number D you write principal Riemann sheet has no pole at n is equal to 0. So let us explore this little bit, what I am talking, huh? So if you want to write it, so if you take this separately, log of 1 minus z, okay, so you know that at z is equal to 0 you have log of 1. So what you will get at z is equal to 0? Log of 1. Yes. But if you want to write this, this log of 1 value is what actually in general? Log of e to the power iota 2n pi. Okay. So that means I 2n pi. This value is I 2n pi. The value of log 1. So this value of log 1 is 0 only at n is equal to 0. And for other values of n, an imaginary value will come. So जो हम कंसीडर कर रहे हैं प्रिंसिपल, सो जो log 1 की वैल्यू 0 है, हम कहते हैं that is not everywhere, that is only on principal sheet when n is equal to 0. See this carefully. Otherwise, if you take n is equal to 1, that means first Riemann sheet. So what is the value of log 1 there? क्या हो जाएगा? I2 pi. What is the value on the second Riemann sheet? The value of log 1? Yes?
Iota 4 pi.
Iota 4 pi. So there will be different values existing on different Riemann sheets. So just be careful about it. तो जैसे हम like we take a problem fz is equal to sine z by z, and we solved it na using z is equal to 0. If I take suppose, so what is z is equal to 0? It can be removed na if you open this sign.
Yes, sir.
So this is also like z is equal to 0 is also a removable singularity here. Okay, so now if you have understood how to just isolate the branch point, all we have to do is we have to avoid the branch point. ये ध्यान रखना. In our integration, all we have to do is in our contour integration involving branch point. So now let us discuss contour integration involving branch point. Okay, so
Sir,
all we have to do,
what is the meaning? सर जो आपने सी पॉइंट लिखाया था z is equal to 0 is a singular point at all sheets except at principal Riemann sheets. लेकिन जो डी पॉइंट था वो लिखा था कि प्रिंसिपल रीमन शीट्स हैज नो पोल एट n is equal to 0.
yes,
और both of them are correct.
so both are different na? The first one is regarding the pole, because if you open it at z is equal to 0, it is a removable singularity.
Okay.
So the value of log 1 is 0 only at principal Riemann sheet.
Okay, sir.
Okay.
Got it.
So अब now please the अब क्या है कि प्रॉब्लम बहुत टफ हो जाएगी अगर if you will try to think about that branch point or branch cut में we have to go very deep, but our requirement is to know what are the branch points, that you know or not. That you know what are the branch points.
Yes, sir.
So we have to use that in contour integration, and please write that in inverted comma. We have to avoid branch points in our contour. So what are the contours that we are drawing? In first case, the contour integration, the contour was given. That was, I told you, just like a limit. But in other cases, the contour was like a substitution. Contour किसकी तरह काम कर रहा था? That was like a substitution. So you have to make intelligent substitution, like you did for 0 to 2 pi. You put mod z is equal to 1. याद है?
Yes, sir.
Then you took a semi-contour to make limit minus infinity to plus infinity. That also you remember? Now,
Yes.
in contour integration, we have to avoid branch point, and there is a theorem that I am going to give you. That theorem is like this. Suppose we have an integral 0 to infinity and x to the power alpha fx dx. Suppose this is what you want to integrate, and the value of alpha is between 0 and 1. The value of alpha is between 0 and 1. So this fx is equal to some px by qx, a polynomial like this, numerator and denominator. And suppose the order of p, the degree of p is m and q is n and m. So this should have greater degree. That means the n should be at least greater or equal by m plus 2. Okay. If the case is like this, then this integration is given by, अभी थोड़ा वेट करना, मैं अभी समझाता हूँ. 2 pi I 1 minus e to the power iota 2, ऐसे याद रख लेना, 2 pi I alpha. Okay, 2 pi I alpha, like this. This is the theorem that we have to use into sum of residue, and in bracket write avoid zero as a pole. Avoid 0 as a pole. This is the theorem. And so right hand side forget. Well, just see what type of integrals we can do. So please see it carefully, everybody. X to the power is alpha. What is x to the power? Alpha. And alpha is between 0 and 1. Alpha is between 0 and 1. So suppose the value, to understand it in a simple way, suppose the value of alpha is half. So this will be x to the power half. And if I consider this, what will happen? If I consider this as a function fz, it will become z to the power half and fz, correct? So z to the power half will become what? Z is equal to 0 will become what?
Branch point.
Branch point. Okay, so this may look you tough, but it is not that tough, because I will explain this to you using a problem. So let me use a problem to explain this. 0 to infinity x to the power minus alpha x plus 1 and dx. Let us solve this problem. So here alpha is between 0 and 1, but here you see the power is minus alpha. So suppose it is half. So here it was half, here it is minus half, correct? So I will change this problem. I will write here 1 minus alpha upon x square, x plus 1 dx. Please check. Is this correct? Oh, sorry, in the question it was only x plus 1. I am sorry for that. And here it will become x plus 1. Okay. In the question it was only like this, x plus 1. And now I have multiplied and divided by x. So now it is okay. it was given here that alpha is between 0 and 1. It was given here. So if it was minus alpha, so now it is okay. 1 minus alpha will be between 0 and 1, but minus alpha will not be between 0 and 1. जिसको समझ नहीं आ रहा है, you can take alpha is equal to half. क्या ले सकते हो आप? Alpha is equal to half ले लो, तो what will happen? It will become x to the power minus half. So now it is not according to our question. So what I have done is I have multiplied x here and here. So now it has become 1 minus alpha. Now it is okay. Okay. So now what will happen? It will become, you see this side, 2 pi I. So now it will become 2 pi I 1 minus e to the power 2 pi I 1 minus alpha. Yes. And summation of residue. We have to avoid 0. I mean 0 पे residue नहीं निकालना है. Okay. Because you know 0 is branch point also. Okay. Now let us see what is fx now. It is a very straightforward. So what is fx? बताओ भाई. Fx for our question will be 1 upon x plus 1.
But sir, px जो quadratic है, that should be greater than equals to m plus 2.
So it has power 2 ना.
But sir, न्यूमेरेटर जो है वो उसकी पावर ज्यादा होनी चाहिए सर.
नहीं उल्टा लिख दिया है क्या मैंने? वो एक
हाँ
बार
यस सर,
नहीं चेंज
ऊपर
कर
m आएगा, नीचे n
चेंज
आएगा
कर लो.
सर.
डिनोमिनेटर ज्यादा होना चाहिए तभी कन्वर्ज होगा.
तो डिनोमिनेटर n पावर n, न्यूमेरेटर m. ओके सर.
Okay. So now we have to calculate the residue for this, and 0 तो करना नहीं है, तो what is the point? Z is equal to minus 1. Please check this. Where we have to calculate residue? Yes, minus 1 na. Okay, so calculate limit z tending towards minus 1 and z plus 1 into z to the power minus 1 minus alpha over z plus 1. Okay, so this will become minus 1 to the power 1 minus alpha upon minus 1. So this will become minus 1 to the power 1 minus alpha minus 1. Correct है ना? So this will become e to the power minus I pi alpha. Please see this. Because minus 1 is e to the power I pi. So what about this? Come here. So this will become 2 pi I into e to the power minus I pi alpha. Bring it down. So it will become 2 pi I over e to the power I pi alpha minus, if you multiply here, what will happen? See this, e to the power 2 pi I into e to the power minus 2 pi I alpha plus I pi alpha. So this is 1 into minus I pi alpha. So it will become e to the power minus I pi alpha. Is that okay? Yes? Up to this it is okay. So it will become pi upon, you can see that 2i can be written here in denominator. It will become sine. So pi by sine pi alpha is the answer. Okay?
Sir, while calculating residue, whole integrand has to be taken.
Whole integrand has to be taken. All of this that you have done earlier also, na? Wait, earlier also, whatever is there inside, you take that, na? So this has no exception. Just fx was to see the power 2 part and the pole part.
Yes, sir. Thank you.
So this is a very nice question. If you have any doubt, please feel free to ask.
एक्सक्यूज मी सर
हम्म
सर वो जो पावर में जो कंफ्यूजन हो गया था ना कि m एंड n का वो एक बार बता दीजिए
अरे डिनोमिनेटर का पावर बड़ा होगा, तो जैसे यहाँ पे देखो x की पावर 2 है, ऊपर x की पावर 0 है.
ओके सर
x to the power 1 minus alpha वो क्यों लिया हमने?
Why? So suppose alpha is, see what is alpha?
0 to between 0 to 1.
Let us take it half. You agree with this? I can take it half.
Yes, sir.
So what will be written here? X to the power
Minus half.
But what was in the theorem? X to the power half.
Alpha.
Half.
Yes.
Now alpha is
Yes.
half. So
Yes, sir.
this was between 0 to 1 according to our theorem. This was between 0 to 1. So is this also between 0 to 1 minus half? Arey bhai, minus half is not between 0 to 1 na?
Yes, sir. Yes, sir.
Huh? It is not
Yes,
between.
sir.
This is not correct. So that's why I multiplied by x. So now it has become 1 minus alpha. That means 1 minus half. So that means x to the power half. That is between 0 to 1. So that was the trick. Got it?
Yes, sir. Thank you, sir.
Anything else you want to ask?
सर
Hmm.
लास्ट में जब हमने e रेज टू पावर माइनस आईटा पाई अल्फा को हम नीचे लेके आए हैं,
हाँ जी.
जब पूरे से मल्टीप्लाई किया है तो ये 2 e रेज टू पावर 2 पाई आईटा की मल्टीप्लाई 1 से भी तो होगी, 4 कहाँ गया?
वो यहाँ पे लिखा हुआ है, आप देख नहीं रहे हो.
ओके सर,
जिसकी वैल्यू क्या लिखी हुई है नीचे?
1. थैंक यू सर.
Okay, I hope.
Sir,
Hmm.
actually alpha can take any value, right? Means in the question it is not mentioned alpha.
Yes.
So
Any
if
value.
alpha is minus 3 or something, then our assumption is wrong, right?
That means you don't understand that alpha can take any value between 0 to 1. How it can be minus?
No, I am telling that in the question.
No. It is a theorem. It is a theorem. Alpha can only. This is not a question. Please remember, this part is not a question.
Yes, sir. Okay.
Hello.
Okay, sir. Okay.
Please understand this. Every integration cannot be performed. That you know, na?
Yes, sir.
Every function can't be integrated. That you know.
Yes, sir.
Some will diverge. For example, if you try to calculate minus infinity to plus infinity e to the power x square dx, so the value will diverge. Okay. So here alpha can be only between this. So when you read something in theorem, you don't change, na? Or you change the theorem also.
No.
So you have to do every. Now you see, you can do as many questions as you want. Just you have to understand this, and then you have to suppose this is x to the power minus half. I can put in denominator x plus 1, x square plus 1, x 1 plus x to the power 4, x 1 plus x to the power 3, and you know to calculate the residue. Yes or not?
Yes, sir. Yes, sir.
So this part is common. I have rubbed that. The 2 pi, I think. And the sum of residue, only you have to remember that avoid z is equal to 0. That's it. Why? Because that is a branch point.
Branch.
So you can do as many as questions. एक question मैंने करा दिया है, आप कोई भी question कर सकते हो. No need to do it again because you know the calculation of residues for different type of functions we have already done. Suppose I put here 1 plus x to the power 2. तो कर लोगे कि नहीं कर लोगे? You will write x plus iota, x minus iota, yes? And you will calculate the residue. Okay? Only 0 should not be included. Fine? So see, if our question was like this, suppose our question was like this, 0 to infinity, x to the power minus half x plus 1 dx. So what was answer? Alpha is half. Pi is the answer. So how compact it is. Can you see that? बोलो भाई, कोई एक आधा लोग तो बोलो, समझ रहे हो?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
So because sine pi by 2 is what? And
1.
you saw that how very intelligently I wrote minus 1 is e to the power I pi. Because if you don't write it, it will not come in this compact form. Yes? So now this was one class, and this is not one question, I am telling you. This is a lot of questions. You can integrate it with any of your older questions. Now, so that was A, integral involving branch points, and complete thing was algebraic. And where was the branch point? It was at 0. Yes, it was at 0. Now the B is, उस पे A लिख लेना, and please change that M and N मैंने गलती से लिख दिया था. सबने correct कर लिया?
Yes, sir.
Everybody?
Yes.
Yes, sir.
Okay. So please see this. The B part, integrals involving log. Because log has also branch points. So that will be the second part, integrals involving log. And suppose I want to solve this integral 0 to infinity log of x square over x square plus 1 dx. This is a real integral and we want to solve this. Okay? Tell me, is that okay?
Yes, sir.
This integration we have to solve. So our that contour, which was a semi contour, that we can use, but we will have to do some algebra, because if you remember, in that contour we had minus infinity. Yaad hai? We had minus infinity, and here there is no minus infinity, and neither it is a इवन फंक्शन कि मैं इसको माइनस इन्फिनिटी से प्लस इन्फिनिटी लिख लूं, दैट ऑल्सो आई कांट डू. एंड log of x, तो जैसे ही fz लोगे you will have a branch point. Where the branch point will appear?
0.
At z is equal to 0. Okay, so let me take this. So I will be using the same semi contour. Please see this, from minus r to some minus epsilon, and then like this, then 0, then epsilon is the radius of a smaller circle, and this, the same semi contour like this. Please see this. So this is the contour that I am going to use. Okay, so this is the real axis and this will be the imaginary axis. This small circle is, let's see, epsilon. That means epsilon is the radius, and this is CR. The R is the radius. So now seeing this, I am writing f of z is equal to log of z square over z square plus 1. Please see this and tell me if that is okay. कोई doubt function लिखने में? Now can I put that as z plus iota, z minus iota, and if this is the line, iota will be somewhere here and minus iota will be somewhere here. Can you see that? Okay, so z is equal to 0 is branch point. Why I have done this? Anybody can tell?
Exclude the branch point.
Just I don't want, I told you the principle is to exclude the branch point singularity.
It has the limit 0.
Okay, so that's why I have excluded this branch point.
So the arrow of that thing should be in the right side, right?
Arrow is anti-clockwise conventionally. That is the positive direction of the contour.
Sir, right axis.
Oh, sorry. So by Cauchy integral formula, contour fz dz is a closed contour that will be equal to 2 pi iota sum of residue. Is that okay? Yes. So now please see it carefully. I will start from this point. So this is a closed contour, then only we can apply it, the closed one. And then I am writing minus r to minus epsilon fx dx plus integral epsilon fz dz plus integral minus epsilon to r, this is r fx dx plus integral cr fz dz is equal to 2 pi I sum of residue. Is this clear? When I am moving on the real axis, so here obviously y is 0, z is equal to x. So that's why I am writing fx dx. Now please see, I want a lower limit equal to 0 and upper limit equal to infinity. So I will install limits r tending towards infinity and epsilon tending towards 0 in this case. and my integrals will become minus infinity to 0 fx dx plus, these will go by Jordan's lemma. I have told you that they will not exist. You can see also by putting the limits actually that they will not exist. So fx dx, this will also go to 0. So what will be equation here? Z is equal to epsilon e to the power I theta. And what will be the equation here? Z is equal to capital R e to the power I theta. So you can put the values here and put the limits and see for yourself that these terms will not exist under this limit. Only these two terms will exist. Okay. And they will be equal to now 2 pi I sum of residue. If there is any doubt up to this, otherwise I will erase this part and start from the,
Sir, please explain this last.
put this limit. So if you put this limit, then this part will become like this will go to 0, this part will become like this, and this will again go to 0, like I told you in the case of semi contour, that that contour thing becomes 0. Okay. और यहाँ पे ये जरूर लिख देता हूँ कि what is my fz, that was log of z square over z square plus 1, correct? That was my fz. So please let us see right hand side, and because the limit of r is now infinity, so I will write it like this. This is minus infinity, this is minus 0 kind of, and 0 which is also 0, and this is infinity. Okay, it is now like this. So that means this iota will be inside and this iota will be outside the contour. So let us calculate, because I want the residue on the right hand side. Let us calculate that residue first. So residue at z is equal to iota. Okay, residue at z is equal to iota. So what will happen? Limit z tending towards iota log of z, sorry, z minus iota log of z square upon z plus iota z minus iota. This will be cancelled, and if you put z is equal to iota, it will become log of iota square upon 2 iota. So this is log of e to the power I pi by 2 square over 2 iota. So that is I pi by 2. So that will be minus pi square by कितना आ जाएगा 8 iota.
Yes.
Because this will become I pi by 2 square over 2 iota. So it will become minus pi square by 8 iota. So put it here. So you will get minus pi square by 8 iota 4. So minus pi cube by 4. Check करना जरा, सही है? Is that okay?
Yes.
Calculation is okay?
Yes, sir. Okay, sir.
So now this we have to deal with. Now this is, please see, check this residue is clear to everybody. Then I will again erase the above part. Residue at simple pole, it was there. Clear hai?
Yes, sir.
So shall I remove this? And what I'm getting now is minus infinity to 0 fx dx plus 0 to infinity fx dx is equal to minus pi q by 4. And let us write fx again here. So it is log of x square upon x square plus 1 dx, and here also log of x square upon x square plus 1 dx. So can you see now what we wanted is now appearing in the equation? Can you see that?
Yes, sir.
What we wanted, 0 to infinity log of x square upon x square plus 1 dx. This is our question. Little difficulty is there, but we will manage. So now I am putting a minus sign here. Please see it carefully. So it will become 0 to minus infinity. किसी को कोई problem? Upper limit changes to lower limit and lower limit changes to, because I want in this form na. And now what I am going to do is I don't want minus infinity here. So I can substitute x is equal to minus x in the above equation. So it will become, please see, मैं यहीं पे change कर रहा हूँ. Please see it carefully. 0 will become 0. Minus infinity will become infinity. This will not change because x will be minus x. Nothing will change. This dx will become minus dx. So this minus will be gone. And log of x will become log of minus x. So changing of limit is clear. Put x is equal to minus x. And now please see, now again your intelligence will, it will become 0 to infinity log of x plus log of minus 1 whole square upon x square plus 1 dx plus 0 to infinity log of x square over x square plus 1 dx is equal to minus pi cube by 4. Okay, because here it is log of minus x, so that means log of x into 1. And what is log of ab? Log of a plus log of b. अभी देखते रहना सब लोग ध्यान से. Log of minus 1, so minus 1 can be written as e to the power I pi, so it will become I pi. Log of minus 1 will become I pi. Is that clear? Now please see this. सभी लोग ध्यान से इधर देखो. A square will become the same. Can you see that? B square and 2ab. So I can write a square will become 2 times 0 to infinity log of x square upon x square plus 1 dx. B square will become minus pi square integral 0 to infinity dx upon x square plus 1, and 2ab. 2ab will become 2 times iota pi integral 0 to infinity 2ab log of x upon x square plus 1 dx, and this will be equal to minus pi cube by 4. Correct? एक रिजल्ट देखो तुरंत आ गया. I can write it here I is 0. Compare the imaginary part. So you got 0 to infinity log of x upon x square plus 1 dx is equal to 0. Complex में यही होता है. Okay? Comparing the imaginary part, right hand side there is no imaginary part. So this integral immediately became 0. And what about the real part? Please see this. This is tan inverse infinity, which is pi by 2. Can you see that? This is very normal integration. Na? Dx upon x square plus 1 is what? Tan inverse x by a. So this will become just pi by 2. Yes? So this will become 2 times 0 to infinity log of x square over x square plus 1 is equal to minus pi cube by 4 plus pi cube by 2. And what this will come? Pi cube by 4. And 2 from this side will make it 8. So answer is pi cube by 8. I hope you like the question. If there is any doubt you can ask. Feel free to ask. I use this integration, which you know, plus 2 integration dx upon 1 plus x square as pi by 2. You can also solve this using contour integration, but why will you waste time? Tell me if there is any doubt at any step.
Sir, what is there in the multiplication of pi by 2? Last second line.
This?
Yes, sir.
Pi square ना? A square.
Pi square.
A square plus B square से आया था ना?
Yes.
Minus pi square. Okay? Okay, so thank you so much.